Hello everyone. So let me start off introducing a member from Vicaria. So I've had the pleasure of working with Vicaria for almost 1.5 years now. And I think it's the only company that I know which does all their development in the public as an open source. And I think it's pretty amazing. Vicaria has been sponsored at brand sponsoring FOSS4G, FOSS4G Brazil, FOSS4G Auckland. So they have been supporting FOSS4G all around the globe, and now we've had the pleasure of having them here with us. So with that, let me introduce Arisa Mikumo from Japan, who is talking more about her work in the Geospatial.
My name is Arisa Mikumo from Vicaria. Nice to meet you. So before I start, I'd like to clarify the title of today's talk actually. So today's title is this. So we are building the open geospatial data platform for everyone. You may have seen this listed online as building open geospatial technology and real work practice. But that is not that, but that is actually what I usually do in my work. I work closely with students, local governments, and community groups, helping them create, visualize, and share spatial data without requiring deep GIS knowledge. If you are interested in concrete use cases of this kind of work, we will be giving another talk tomorrow morning in Room 1 titled GIS as a community tool, using reverse visualizing citizen workshop. So by today, I'd like to focus on reverse and talk about how we are building an open geospatial data platform that anyone can use. So, thank you for coming to this presentation. Thank you. I know many of you are maybe probably looking forward to today's gala dinner. I'm looking forward to. So thanks for being here. So today, I'm going to give us also talk about our company and our product, which I believe many of you already knows. So first, let me talk about the company first. So we are Ucaria, actually not yours. So Ucaria is a startup company based in Tokyo, Japan. And yours is our product we developed. So we mainly develop geospatial software, and we are also a very international company. We also have a team member in India, and some of them are here with us today. And also, like Jason mentioned, we work with Jason together as well. So let's go to the product part. So we have several products on Reverse. So Reverse has 3 services on it. So one is Reverse CMS, which is a content management system. That one, Reverse CMS. And also we have Reverse Visualizer, which is used to visualize geospatial data. And we have Reverse Flow, which helps process, convert, and connect different types of data, different types of geospatial data. We mainly have 3 core products, and all these products are open source. You can access all source codes of it. So we're very honored to be your top sponsor over the last few years. We were a Diamond sponsor in Kosovo 2022, a Diamond sponsor in Belém in 2023, and a sponsor in Oakland 2025. And we were sponsoring again this year, here in Nasi. 2 years ago, our company identified and logo are quite different. Currently, our logo is, but 2 years ago, it's a different. So you may have noticed that our logo is very different compared to last year. So that's because we changed it significantly. So after 2 years ago, we were mainly focused data visualization. But we realized that visualization of geospatial applications. So we decided to redefine our identity. Now, instead of focusing on your visualization, we focus more on data itself. But why data? Because we are currently living in a world of overwhelming information. So, while preparing this presentation, I was thinking about how much data generates in the world. As of 2024, around 149 zettabytes of data have been generated, consumed, or copied worldwide. Okay, zettabytes. Is there anyone who knows or who uses zettabytes data? Nah, right? I actually didn't know zettabyte. So kilobytes, megabytes, gigabytes, terabytes, petabytes, exabytes, and zettabytes. It's quite big, right? So I only megabyte, gigabyte, terabyte, okay, so but the exact number is not important. But what matters is that we live in a world overflowing with data. The real question is, are we making good use of it? So there is a concept called spatial data infrastructure, which refers to our framework of geospatial data, metadata, users, and tools designed to enable efficient and flexible use of geospatial data. This is not just about software, but also about governance, standards, and policies. Around the world, there are many open data initiatives at local, nation, and regional level, such as data.gov and Inspire Europe, and a major initiative called Project Plateau in Japan as well. So let me just introduce Plateau. Agree? So Plateau is an open 3D city model project led by the Japanese government. It provides not only the geometry but also attribute information such as construction period, building use, and structure. So depending on the city and the specific data set, in addition now, it includes various types of other data such as load, food list, and industrial map, and livelihood assets. So one important concept in open data is a fair principle. You might know. Fair, F, viable, A, accessible, I, interoperable, and reusable. That is like a fair principle we use in that is important concept in open data. So these principles describe what is needed to make open data truly work. So even though we know these principles and have many initiatives and tools, it still feels like we are not fully there yet. As a GIS worker, I often struggle to find an exact data I need to solve real-world problems, even when data exists. But it's not always easy to access or reuse. We can relate. Yeah. Okay, so from that program, this led us to think about GitHub. You guys might know GitHub. So GitHub has enabled massive collaboration in open source software with more than 2,000 million public repositories. We wondered why we couldn't apply the same idea for open data. So we realized that business model also matters. Public open data should be free, just like public repository on GitHub. GitHub charges for private repositories, but encourages open source towards sustainability, but our goal is to encourage open data and sharing. Okay, can you hear me right now? Thank you. So those three are main our core products, and one is a Rears Flow. This is data conversion system, and one is a Rears CMS, that is a content management system, and that one is like data. Rears Visualizer. It's a data visualization system. Okay, so let's go from Rears Flow. Okay, so Rears Flow focuses on interoperability. It helps convert and process various geospatial data formats, such as shapefile and geodesic. So once your data is processed and interpreted, it goes through Flow. You need a place to store and manage it, right? So that's where Rears CMS comes in. Okay, so Rears CMS. Rears CMS is the core of our platform. It allows you to define data schema, collaboratively manage data in the cloud, and publish data sets in geospatial formats via APIs. Now you have the data managed in the CMS. The final step is to make it visible and understandable for everyone. That is the goal of this visualizer. So Rears Visualizer is a web-based tool for visualizing geospatial data. Its features are powerful styling language and a plugin system that allows for extensively. This is a slide was quite quick, so can you show our flow first? Okay, so yeah, so this is a how visualizers looks. Okay, let's just and so one example of our work is a Japanese government project involving more than 250 municipalities. That is actually a plateau, as I mentioned before, as open source data. So this is a plateau project, and they collaboratively manage and update open data using Rears CMS, and the data is made accessible by the APIs. So we also actively invest in R&D projects that push the boundaries of geospatial technology. I will introduce three our R&D projects. Okay, so first is this. Okay, so first we are building the foundation infrastructure for Project Plateau, the 3D city model project I mentioned earlier. So supporting both its data management and high performance visualization. Our core products, Rears CMS and Visualizer, are the engine supporting this national initiative. So I'm going to introduce the second one. So separately, we are developing Nagala. This one. So our next generation map engine built with Rust and WebAssembly. So one of its key features is its handless architecture. This allows for flexible advanced visualization and pluggable rendering engines, optimizing both GIS logic and the rendering process for maximum performance. Okay, I'm going to do three. We are also working on the project. It's called Links Beta, a system that applies AI to structure large volume of unstructured government documents. I think that's all you know. Much of governance data is still trapped in PDFs. This data can automatically extract and transform this information into massive, readable data. So if you are interested in more R&D projects, please stop by our booth. We'd love to show you more. Thank you. So we used to focus mainly on visualization, but now we believe that open data itself is a key factor. Open source software is important, but open data should also be treated as a digital public goods. So in 2026, we plan to release improved version of Rear's Flow and our map engine, Navala. We also hope to sponsor this conference again next year in Hiroshima. Actually, next year's international FOSS4G will held in Hiroshima, Japan. I urge all you to come. And to do that, we need a strong user community, so we encourage you to use Rears and share it with others. So conclusion, in summary, open source geospatial software is essential, but open data is equally important. Open source plus open data is the future. Thank you for very much listening. We are very honored to be a sponsor again this year, and we hope to support this community in the future as well. Thank you.